Hello, welcome back from a long break of tricks. We're back again. This video is to continue from where we stopped on sort. If you remember, in previous videos I introduced sort. We discussed addition and subtraction of sorts, multiplication and division of sorts, rationalization of sorts, and simplification of sorts. And I promised that in our next video we are going to look at questions, WAEC, NICO, JAM questions, possible questions that can come from sorts, because from what we've done there are basics that you need to know and basic rules that govern sorts, but those did not give us actually the applied questions that we can expect in external exams. So this video is going to do just that. So pay rapt attention. Don't forget to comment, like, share and subscribe if you've not done that. Given in WAEC, we have this question. Given that bracket root 3 minus 5 root 2 close bracket times bracket root 3 plus root 2 close bracket is equal to a plus b root 6. Find a and b. So if we look at this question, I have told you from our introduction to sorts and other questions we've solved and solved that the basic thing you always require to do in sort are either to simplify a sort to its lowest form or to take back a simplified form to its original form, or to rationalize a sort to add or subtract one sort from another, to multiply or divide one sort with another. These are the things you should have at the back of your mind. So knowing this, when we see this kind of question, they say that this is equal to this, find a and b. Mathematically, what we are meant to do is to either make a plus b the subject of the formula to know what a would be and b would be, or we rewrite in sort. It is always advised that you solve this left hand side of the equation to look exactly like the right hand side, so that we'll have an integer plus another integer, then root 6. If we have that integer becomes a, the second integer becomes b. So that is what we are going to do to simplify this left hand side to look like this right hand side. And looking at what we have at the left hand side, to simplify we need to open the bracket, because root 3 cannot be subtracted, 5 root 2 cannot be subtracted from root 3. Neither can root 3 be added to root 2 because they are not similar sorts. So we open the bracket. Remember, in opening the bracket, we use this first term to multiply the entire bracket. That is to say, root 3 multiply root 3 plus root 2. We also use the second term, which is minus 5 root 2, to multiply root 3 plus root 2. And that is equal to a plus b root 6. So if we use root 3 times multiply root 3, I told you that if similar sorts, exactly the same sort, multiplies each other, the root will go, because root 3 times root 3 will give you root 9, and the square root of 9 is 3. So root 3 times root 3 is 3. Root 3 times root 2 is root 6. Because sorts that are not similar can actually multiply. It is only in addition and subtraction that they must be similar. So root 3 times root 2 is root 6. Then come here, minus 5 root 2 times root 3 is minus 5 root 6, because root 3 times root 2 is root 6. Okay, then minus 5 again times root 2 times root 2, because they are similar, will be 2, because the root will now disappear, because root 2 times root 2 is root 4, and root 4 is 2. Then that is equal to a plus b root 6. If we simplify further, we'll have 3 plus root 6 minus 5 root 6 Minus 5 times 2, we have minus 10 is equals to a plus b root 6. And of course, root 6 minus 5 root 6 is just like saying, I told you that to be in a safer side, we can always assume this surd to be a variable so that the one we are conversant with. If this is x, you have x minus 5x. You know, when you say x minus 5x, you have minus 4x. So we're going to have 3 minus 4x, which is 3 minus 4 root 6, where the root 6 is the one we replaced with x. Then minus 10 is equal to a plus b root 6. If we collect like terms, this term and this term are like terms. So we're going to rewrite it to be 3 minus 10, then minus 4 root 6 equals a plus b root 6. 3 minus 10 will give you minus 7 minus 4 root 6 equals a plus b root 6. So if you look at what we have here, you will realize that what we have at the left hand side looks like what we have at the left hand side. You have root 6 here, you have root 6 here. The coefficient of root 6 here is b, the coefficient of root 6 here is minus 4. And then the constant, the one that is alone, that is not an irrational number, is a. Therefore, the rational number on this other side is minus 7. So we can say that a is equal to minus 7 and b is equal to minus 4. And we've been able to get our a and b as we expected to do in that exam. So if we look at this other question, evaluate without using calculator or tables 3 over root 3 open bracket 2 over root 3 minus root 12 over 6 close bracket. Now, there is no singular method of solving this, but whichever method you will use, one, you will ensure, since we're having fractions here, you will ensure that the answer you're going to get is not going to have an irrational number as the denominator. There should not be roots at the denominator. Secondly, is that when you are when you are simplifying an expression, you will either solve the bracket. Remember, the bracket comes first in our board mass that we know. So we are going to solve what we have in this bracket before we consider this one outside. Or one can actually decide to expand or open the bracket. So I would prefer to solve what I have in the bracket. So I would say that this we have here is equals to 3 over root 3 open bracket. Solving what I have in this bracket, I can decide to rationalize this and simplify this, because this root 12 is not in its simplest form. So I can reduce it. Okay, let's leave this like this, since we have root 3 also outside. Instead of rationalizing, just let it be. We have 2 over root 3. Let us simplify this root 12. So we now have minus. Remember that root 12, the perfect square that can divide 12. Remember when we are doing our perfect square, we have 1, 4, 9, 16, 25, and thereabout. So amongst these numbers I have mentioned, it is 4 that can divide 12 without remainder. And when 4 divides 12, you have 3. So 12 can be replaced with 4 and 3 all over 6. Close our bracket. Then this is equals to 3 over root 3 open bracket 2 over root 3 minus this 4 will come out as 2 because square root of 4 is 2, then root 3 over 6, and then we'll close the bracket. This can further be simplified as 3 over root 3 open bracket 2 over root 3 minus 2 here, we divide this 6 to give us 3, so that we'll have root 3 over 3. And then from here, we can now decide to open our bracket. Of course, opening bracket, you will use this to multiply both this and this. So when we do that, we're going to have 3 over root 3 times 2 over root 3 minus this times this again, 3 over root 3 times root 3 over 3. So when you see this, you are going to have 3 times 2 will give you 6. Root 3 times root 3. Remember what I said, the root will go and you have 3 minus 3 times root 3. You have 3 root 3. All over root 3 times 3, you have 3 root 3. And you will realize that what you have here is what you have here. And this can actually cancel out this. And that will give us 6 divided by 3. 3 divided 6 will give you 2. Minus this over this will give you 1. And the answer to this, shockingly, is equal to 1. So, surprisingly, the whole of this expression that we have here has turned out to be just 1. So we have another question that says simplify root 50 minus 3 root 2, open bracket 2 root 2 minus 5, close bracket, minus 5 root 32. To simplify this, like I said, we are going to solve it like a normal mathematics will solve, but we ensure that they are all in their simplest form. So this root 50 has to be reduced to its simplest form. Of course, root 2 are already in their simplest form. Root 32 also has to be reduced in its simplest form. And you remember, what we need to do is to look for a perfect square that can divide what we have here without remainder. We have perfect squares 4, 9, 16, 25. Of course, from what I have mentioned, 25 can go here. From what I have mentioned, 16 can go here. So if 25 divides 50, you have 2. So I can replace 50 by 25 times 2. Then minus 3 root 2, this one that is already here. Open bracket 2 root 2 minus 5, close bracket, minus 5. Then instead of 32, if 16 divided 32, you have 2. So I'm going to have 16 times 2 in place of 32. And that will be equals to root 25 is 5. So I will have 5 root 2 here. Minus, I can decide to now open this bracket. Use what you have here to open this bracket. So I have minus 3 times 2. I'll have minus 6. Root 2 times root 2, I will have 2. Minus 3 times minus 5, I'll have plus, because minus times minus is plus. I'll have plus 15. Then root 2, there is no root here, so the root 2 will remain. Then we're done with this bracket. Then you have minus 5 here. Minus 5 times the square root of 16 is 4. So times 4, then root 2 will remain there. So what we are going to have here is 5 root 2 minus 6 times 2 is 12 plus 15 root 2 minus 5 times 4 is minus 20, then root 2. We collect like terms. Those ones that are not carrying roots will be put together, and those ones that are root 2 will be put together. So we have 5 root 2 plus 15 root 2 minus 20 root 2, then minus 12. Remember, whenever you are moving any number, it goes with the sign before it, except it is crossing the sign of equality. That is when the sign changes. But if you are moving this 12, minus 12 to anywhere at the right hand, still at the right hand side of this equality sign, it remains, it goes with the minus. So 5, remember I said you can take this to be x, 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 or variable, whichever variable. So just in order for us to not confuse ourselves, 5 plus 15 is 20. So you have 20 root 2 minus 20 root 2 minus 12. 20 root 2 we subtract 20 root 2, and our final answer is minus 12. And that is what we've gotten by simplifying root 50 minus 3 root 2 bracket 2 root 2 minus 5, then minus 5 root 32. That means that if you punch the whole of this correctly in your calculator, you're going to get minus 12 as your final answer. And that is how to do that. So let's look at one other question. We're asked to simplify 8 minus 4 root 18 over root 50, leaving your answer in the form a plus b root n. Now, you don't have to bother yourself in getting this. All you do is to simplify what you've been given, and it will definitely result to something like this. So if you look at this question, you'll realize that one of the things I asked you to make sure is that there should be no root at the denominator. So we have to do rationalization here. Another thing that you should see here is that these two numbers, these two irrational numbers or numbers in the roots are not in their simplest form, so we have to reduce them to their simplest form. So let us start by reducing these numbers to its simplest form. We have 8 minus 4 root 18 all over root 50. Then between our perfect squares, we have 4, 9, 9 that I've mentioned can divide 18. So quickly we replace 18 with 9 times something. 9 times what? If 9 divides 18, you have 2. So 9 times 2 is 18. The next is 4 squared is 16. You cannot divide 50. 5 squared is 25. So 25 can divide 50. So we replace 50 with 25 times 2. And you can see we have been able to reduce this. So if you simplify further, we have 8 minus 4. The square root of 9 is 3. So we have 3 brought out of here. And then you have root 2 remaining inside. Then here 25, the square root of 25 is 5, then you have 5 root 2. So if we go further to simplify, 4 times 3 will give you 12. So we'll have 8 minus 12 root 2 all over 5 root 2. But we cannot leave it like this, and you cannot subtract 12 root 2 from 8 because they are not similar. This one is not carrying root, this one is carrying root 2. So what do? And we cannot leave it like this. We have to rationalize. Rationalize by multiplying both the numerator and the denominator by the conjugate of the denominator. And what we have at the denominator is root 2. That's what we can rationalize with to eliminate the root. So we are going to say times root 2 over root 2. Okay, so if we do that, root 2 times 8, we have 8 root 2. Root 2 times 12 root 2, you have minus 12 root 2, you have minus 12 times root 2 will give you 2, because root 2 times root 2 is root 4 and the square root of 4 is 2. So we have 5 here, then root 2 times root 2 will give you 2 as well. So that will make it to be equals to, we have here 8 root 2 minus 12 times 2 is minus 24 all over 5 times 2 is 10, and this is our answer. You can decide to break them because they said your answer should be in the form of a plus b root n. You have to separate it. So we have 8 root 2 over 10 minus 24 over 10. Mathematically this is correct because the 10 is dividing everything at the numerator, so you can separate it that way. Something can be reduced here. This 10 can be reduced. 2 can divide this to give us 4. 2 can divide this to give us 5. So you have 4 over 5 root 2 here. Then here we have minus 2 can divide 24 to give us 12. 2 can divide 10 to give us 5. So we have this. So but it's still not in this form. For it to be in this form, the first number should be a number without roots, and the number without roots here is minus 12 over 5. So we are going to write minus 12 over 5 first. Then the second number is a number that with a root, so this, and that is what? Plus 4 over 5 root 2. So if we are asked to write it in that form, this is the form it should be written. If you are asked your a is minus 12 over 5, your b is 4 over 5, and your n is 2, then that is the answer to this question. Thank you for watching. Don't forget to like, comment, share, and subscribe if you have not. See you next time.